Hello everyone. In this video, we will be discussing about the solution for the question number 59 that was asked in GATE 2023. And this question is from analog circuits. So the question is the Zener diode in circuit has a breakdown voltage of 5 volt. The current gain beta of the transistor in the active region is 99. Ignore base emitter voltage drop VBE. Can consider this as zero voltage, the VBE. The current through the 20 ohm resistance in milliampere is. You have to find the current through this resistance. So the correct answer is 250 milliampere, and we will see how we can reach that answer. Before going to the solution, we will have some small discussion about Zener diode. So Zener diode is like a normal diode, but some difference in the operation is there. So in the forward bias region, whenever the Zener is forward biased, it will similar to that of a normal diode. We can make it consider that as a 0.7 volt, whatever the voltage value, we can replace this xenon diode as that value, same as that of the diode. But in the reverse bias, there are whenever the reverse biased voltage of a xenon exceeds some particular value, that is the xenon voltage, we can replace this xenon voltage as a constant voltage source. Similar to here, we can replace that as a voltage source as well as a series resistance in case of a reverse bias voltage. But in case of normal diode, it is not possible. We can't replace that normal diode as a voltage source and series resistance whenever it is in reverse bias. But in case of Zener diode, we can replace that. So in reverse bias region, there will be small reverse current flow in the Zener diode, that is the knee current. And usually this knee current can be assumed to be zero unless value is mentioned. For gate values, that is this current, whenever there is a reverse bias across this Zener diode, we can consider this current as zero. This one, this I knee current as zero. For gate questions, usually we solve like that. This will consider as zero. When the reverse voltage applied on Zener diode exceeds certain threshold, that is when it is exceeding this value, that is the Zener voltage, exceeds some threshold, the diode starts to conduct a large current. This is known as a Zener breakdown. So whenever the reverse bias voltage across the Zener diode exceeds this threshold, it will start to conduct. And you can see its slope is like this. It is like a straight line parallel to the y-axis. So at that case, this is the reverse biased Zener diode plus minus. And we can replace this Zener diode with this diagram. You have to check the polarity also. Whenever this we can do whenever the reverse bias across this Zener diode exceeds some particular threshold. That threshold will be mentioned in the question, and here it is mentioned as 5 volt. So whenever the reverse bias voltage across this Zener diode is more than 5 volt, we can replace this with a diagram like this. So this RS usually we calculate from this slope, the inverse of this slope. But we can most of the cases we can take it as zero. This RS we can take it as zero. That is when the occurs Zener breakdown occur. The voltage across the Zener diode equal to VZ0, that is VZ0 plus IZ into RZ, where RZ is obtained from the slope of the straight line in the reverse bias region. That means this line. And here this resistance, whatever mentioned here, is obtained from this slope. This is in the forward bias region, and this is in the reverse bias region. So we can obtain that as a 1 by slope. Usually RZ is 0. We can consider that as 0. Then the voltage across the Zener diode is constant, irrespective of the current flowing through this. This is very important. We can replace this Zener diode as a voltage constant voltage. Now we will go back to the question and its solution. We will check the circuit. So we'll have a input voltage here, 7 kilo ohm resistance here, and 10 kilo ohm resistance here, 20 ohm resistance here. So we have to verify whether this is in active region or saturation region or cutoff region. So in this case, it is in active region. So we can proceed. That's the first thing that we have to verify. If it is in active region, then only we can apply that B equal to beta equal to 99. So now it is in active region. So we will see 25 volt is here. So this will be positive. This is connected to the ground. So this will be negative. So now this is reverse bias. You have to notice that this is the reverse bias, but we don't know whether it is that reverse biased voltage exceeds the threshold voltage, because we can see here when only it is exceeding the threshold voltage it start to conduct, otherwise the current can be zero. So we have to we have to see whether it is operating at this point or operating voltages reverse biased voltage less than this voltage, that you have to see first. But here, usually in these cases, questions of this kind usually happen. Two cases are there, but we are not sure. Here, the two cases are anyway. This is reverse biased. The two cases are whether it is operating the reverse biased voltage is uh, less than that Zener break voltage, or it has overcome that threshold. We don't know. Two cases are there. Will it be in the breakdown region or not? We don't know. So in these cases, usually we make assumptions. So we can either assume that this is in the breakdown region, or we can assume that this is not in the breakdown region. The current passing through is zero. At that case, we can open this. Suppose if we are assuming that it is operating in the breakdown region, we can replace this with an voltage source as mentioned here. We can replace with this Zener diode as a voltage value with the polarity shown in the picture. So if you are assuming it is operating at the breakdown region, we can replace this as with a voltage value. But if it is not operating at the breakdown region, the current will be zero as shown in the graph. Then we can make it as a open circuit. This we can make it open. So what assumption we have to take while make? So one tip is while making assumptions, make the first assumption that simplify the circuit further. Suppose as I told, there are two assumptions possible. One, we can either replace this with a voltage value, or we can open circuit this. We can disconnect this, open circuit this branch. So which will make the circuit simpler? Obviously, open circuiting, right? Because if you are adding one more voltage source, we are adding more things into the circuit. That will make the calculation complicated. We don't know whether the assumption that we are going to take is correct or not. We have to verify that. So not to verify, we have to check with those two assumptions. So if you are making the circuit more complex, it will take more time to solve the circuit. So the best thing is make a simple circuit. Make the circuit simple. So for that, the assumption that we can take is open circuit is. We are assuming that it is reverse biased, but the voltage across this is less than the 5 volt. The reverse biased voltage is less than 5 volt, because it is in the question it is mentioned. And the breakdown voltage is 5 volt. So we will assume that anyway this is in reverse bias, that we confirmed, but the voltage across this is less than 5 volt. At that case, we can make it as an open circuit. So that is and that will simplify the circuit. We are removing one component from the circuit, so it will make the analysis easier. So that is what I mentioned here. Here, consider the assumption that the Zener diode is not operating beyond its breakdown voltage. In that case, the current through the diode is zero and it is open. So we can simplify this circuit as this. Now we can solve the circuit. We have a 25 volt, 7 kilo ohm, and 10 ohm here, 20 ohm here. So we will take this loop and apply KVL in this loop, Kirchhoff voltage law. So here we have 25 volt, applying KVL through 25 volt equal to IR. That is IR is same as IB because it is open circuit. because of our assumption. And we have to, okay, IR equal to IB and IE equal to IL, because no current is flowing through this. This is open. We are assuming that, and we have to check if this assumption is correct or not. So with this assumption, we simplified this circuit, and we will solve this KCL, this KVL loop. So you see, what was our assumption? The voltage, this voltage is less than the general voltage, V less than Vz, 5 volt. So that was our assumption, and that we have to verify later. So now from the loop we will have IB 25 equal to IB into 7K plus VBE. You can see 25 equal to IB into 7K plus VBE plus IE into 10 ohm plus IE into 20 ohm. So in the question it is mentioned neglect VB, so we can take it as 0. Then we will have 25 equal to IB into 7K plus 0 plus IE into 30. Now since it is in operating saturation region, IE equal to IB into 1 plus beta. This is a fundamental equation that we always have to keep in mind whenever we are solving or going for questions from analog circuits or from BJTs, bipolar junction transistors. So whenever we are approaching a question, you have to keep some fundamental equations, and this is one of them. IE equal to 1 plus beta into IB. So that is IE equal to 1 plus 99 into IB, that is 100 IB. So that we will substitute here, and we will get IB equal to 25 by 10,000, that is 2.5 milliampere. So in the question it is asking IE, right? So IE equal to nothing but 100 into IB, that is 250 milliampere. And we got an answer with IE equal to 250 milliampere. But we have to verify whether our assumption is correct or not after solving this circuit. So what was our assumption? The voltage across this is less than 5 volt. If it is correct, then whatever the answer we got is correct. If it is wrong, then our assumption is wrong. Then we have to go for the second assumption. And then in the second attempt, we will get the answer, because the first, if assumption is wrong, second assumption obviously will be correct. So we will check our assumption whether the voltage is less than Vz, that we have to check using the whatever the current we got. So now check the assumption. Our assumption was the voltage across the Zener diode is less than the Zener voltage, that is given as 5 volt in the question. So voltage across the Zener diode we will see. This is the voltage across the Zener diode. What is this? Consider this loop. You see this loop. We will apply KVL here. So plus V equal to VBE plus IE into 10 ohm. So that we will apply here. Voltage across the Zener diode equal to VBE plus IE into 10. VBE is 0, it is mentioned in the question. So IE into 10 means 250 milliampere into 10 ohm, that is 2.5 volt. So 2.5 volt is less than 5 volt. Our assumption is correct. The voltage across the Zener diode is less than its breakdown voltage. So our assumption is correct. If the assumption is correct, then whatever the answer we got is correct. So the correct answer is 250 milliampere. So you have to take care whenever we are taking an assumption. The best thing is try to make the circuit simpler, not make it complex. If you are taking the assumptions that the voltage across this is, the reverse biased voltage across this is greater than 5 volt, we have to add a voltage source here. You have to solve it. Then it will become more complex because we are adding a voltage source here. Don't make it complex. Make it simpler. So open circuit is first assumption always should be simpler assumption. Open circuit is, it will make the circuit simpler. So the correct answer is 250 milliampere. And if you want to know more about xenon diode and this bipolar junction transistor, you can refer to these NPTEL videos. This will be useful for you. I hope you found this session useful and you understood the answer. Thank you all.